This is section 1.3, that's chapter 1, section 3, titled Functions and the Representations. Let's start with what a function is. So the definition is, a function is a relation in which each element in the domain corresponds to exactly one element in the range. A relation is just a set of XY pairs. Okay, so that means we can see them written, for example, like they're written in coordinate form, like the coordinates -3, 4, right, where x is -3, y is 4. We might see it as a graph of something. All right, some things to know about how we write these things, and that's one of them that we just talked about, that the points might be written as coordinates, or that we're referring to points and they have coordinates. Another thing is that we write a function in the form f of x equals or y equals, and what that means is that y is the same thing as f of x. Each valid input has only one output, and that is the definition restated. The independent variable is x, or whatever other variable represents x, and the dependent variable is y, or whatever other variable represents y. And I say that because sometimes we use, instead of x, y, we use a comma b, or t comma h, or something like that, right? Some strange thing. So for example, f of x might be written h of t, yeah, and y might be represent the height of an object. The domain is the set of inputs, which is whatever values of x there are included in the function, and the range is the set of outputs, or the values of y that are included in the function, or in all the points. All right. We can write f of -3 equals 4, or we can write that same information as the point -3, 4, the point with coordinates -3, 4. Notice that -3 is the value of x and 4 is the value of y, and the way we say it, f of -3, which is f of x, equals, and the value of y is 4. Also, one other thing is, when sometimes you see an equation like y equals x squared, or y equals 2x minus 5, and in those cases we can, instead of writing y equals, we sometimes write f of x, and that's just function notation, so we could write f of x equals x squared, or f of x equals 2x plus 5. All right. There's something that we call a vertical line test, and it says if every vertical line intersects a graph in at most one point, then the graph represents a function. And we use that, it's that vertical line test, when we have the points in the form of a graph. Yeah. So if you see the graph of a line, for example, you might use the vertical line test to test whether it's a function. All right, so let's look at some examples. Determine if the relation is a function and explain your answer. So number 1, and we'll do A, and we'll leave B for later. So I'm going to do A. And so A, is this a function? Notice it's a set of infinitely many points in the shape of what is called a parabola. And we can use the vertical line test, and we check to see any vertical line that I draw crosses that parabola at only one point, or at most one point. Okay, so therefore this is a function because it passes the vertical line test. I'm just going to say yes for A. All right, number 2, we'll do A also. And that says, is this set of points, right? Is this set of points, which is a relation, is it a function? And so what we're checking is it true that each input has only one output? That means that each value of x is matched or paired with only one value of y. Well, in this case, that doesn't happen because the value x equals -3 has two different outputs. There's the point -3, 4, so the output for -3 there is 4. And then there's the point -3, 5, so the output for -3 there is 5. And so therefore, because -3 has two different outputs, that is not a function. And number 3 will do B. And so notice the different ways to represent a function, right? So the first, number 1 was a graph. Number 2 was a set of points written as coordinates. And then number 3 is actually in the form of an equation, either one we do. I'm going to look at letter B. And letter B says x plus y squared equals 5. Does that represent a function of y? in terms of x. And so the way we do that is we want to solve for y. So I'm going to subtract x. I'll have y squared equals 5 minus x. And then when you're solving for a square, you have to take the positive or negative possibility. So if y squared equals 5 minus x, then y is plus or minus square root of 5 minus x. All right. And so does that represent a function? Well, you'll notice any value of x I pick, let's say 1. 5 minus 1 would be 4. Square root of 4 is 2. However, the plus or minus means that I have two different values of y, a positive 2 and a negative 2. So for x equals 1, I had two different outputs, a positive 2 and a negative 2. So therefore, this is not a function because x equals 1 has two different values of y associated with it. All right. Let's go on and look at interval notation. And interval notation is just a way of writing a set of points, but really we use it when we have a segment of the number line that we're including as those numbers that we're talking about. So let's take a look at what that means. So suppose we're looking at the points x, values x that are between -3 and 5, not including -3, including 5. So if we graph that on a number line, so notice this is really just some set of numbers that we can put on the number line. A -3, I'm going to put 0, and I'm going to put a 5 there. Okay, so -3, and the way we graph points is we usually shade whichever points we want to include. Here we want to include all the points between -3 and 5, but not -3 and not 5. And yes, 5, I'm sorry. So to say this, I'm going to say, I'm starting at -3, so I'm going to put a bubble on -3. And then I'm not including it, so I'm not going to shade it. I'm going to stop at 5, and I am going to shade that because I am including that as one of the values of x that is valid. And then I got to shade everything in between because I'm including all the numbers from -3 to 5. Not including -3, but including 5. So we look at that segment of the number line. The starting point is -3 on the left, 5 on the right, and in interval notation we just write those two starting points. On the left -3, comma, on the right 5. And then to say that we're including or not including, we use a bracket, that's a square, like a square parentheses to include, and then the round parentheses to not include. Okay, so in interval notation we have open parentheses -3, comma 5, and then the bracket to close off the interval. All right, let's try x. X is less than or equal to 0. So I'm going to graph it first. So less than or equal to 0 means all the numbers to the left of 0. And so I include 0. So I'm going to put a bubble on 0 and shade it. And then all the numbers to the left of 0 I'm going to shade. Yeah, so it's the numbers to the left of 0 including 0. So my left endpoint is actually -infinity, but there's no such number, so we can't put a bracket, we put a parentheses anytime we have infinities, comma, my right endpoint is 0, and that is included, I put a bracket. All right, and then the one other one, and we'll leave the other ones for class, but this one, x is less than -1, or x is greater than or equal to 2. And so if I were to graph that, that's really two intervals. X is less than -1 would be to the left of -1. The circle will remain unshaded because it's less than, not less than or equal to. And then greater than or equal to 2 means to the right of 2, but 2 is shaded because it's greater than or equal to. And so I have two intervals, and so when I write interval notation, I must write the two intervals. So it's from -infinity to -1, not including -1. You cannot include -infinity because it's not a number. Union, and you use a symbol that looks like a U. It's not a U, but it looks like a U. From 2 to infinity, including the 2. So that means we put a bracket on the 2. All right, I'm going to stop this video at this point, and we'll continue with the second portion, the next page, on the next video.